So that was one example. Let's now work with 180 degrees, which is the same thing as pi radians. Okay. All right. Okay, so now we want to know what our point P is. Okay, so as before, we want to draw the unit circle like so. So here's our x, here's our y, okay? Now really, again, you want to figure out what P is. Although with 90 degrees, and really here with 180 degrees, you'll see it's actually pretty easy. It's just visualization. Because again, a full rotation would be 360 degrees, okay? So for 180 degrees, that would be half. So you're going to end up here. So again, this is an angle in standard position. The vertex is at the origin. The initial side is on the positive side of the x-axis, right? And again, if I were to rotate all the way around, that would be 360 degrees. So half of that would be 180. So we're going to end up here. Okay, so what's our point P then? That's going to be this point, which would be -1, 0, right? You can see we're on the negative x-axis, okay? That's what the terminal side lies on, and that's why P has to be -1, 0, okay? All right, so now our x, right, in the definition is -1. Y is 0, so let's calculate the trig functions. So cosine of our angle theta, okay, which is again cosine of 180 degrees, cosine of pi radians, right, which is equal to just cosine of pi, and that's equal to -1, okay, because that's again our x. Sine of our angle theta, right, that's sine of pi, right? I mean, I could write out all this here for sine of 180 degrees, sine of pi radians, but for time consideration, I'm not gonna. So we're gonna get our y, which is 0. Tangent of theta, which is tangent of pi, okay? Well, that's y over x, that's 0 over -1, which is 0. Secant of theta, that's secant of pi, right? Okay, yeah, right. So that's going to be 1 over x, which is 1 over -1 actually, which is -1. Cosecant of theta, which is cosecant of pi, that's 1 over y, but y is 0 in this case, so this is not defined. Okay? Because again, y is 0. And likewise, cotangent of theta, okay, that's equal to cotangent of pi, but that's not going to be defined because that's x over y, so this is also not defined. Because again, whenever y is 0, cotangent and cosecant are not defined because you're dividing by y. Okay, now let's do 270 degrees. But again, that's actually pretty easy to do as well. Well, it's easy to figure out what P is. So I'm drawing the unit circle as before. Okay? Well, 270 degrees, if we have the angle in standard position, 270 degrees, it's 3/4 of a complete rotation. Because 270 degrees is 3/4 of 360 degrees. So if we were to rotate, we're going to end up down here. 3/4, okay? So that's what this rotation is going to look like, okay? Okay, so now the question is, what is this point here, right? That's our P, which in this case is going to be 0, -1, okay? I mean, I guess if you really wanted to, well, actually, no, let me not say that. Okay, so from here, I was going to say something about a clockwise rotation, but this is fine what I have. So here we have our p, okay? And now let's get the trig functions. Cosine of theta, right? That's cosine of 3 pi over 2. That's our x, which is 0 here, right? Sine, so again, x is 0, y is -1. Sine of theta, which is sine 3 pi over 2. That's our y, which is -1. Okay, so tangent of theta, right? That's going to be tangent of 3 pi over 2. That's y, okay, so that's going to be y over x, so this is not defined. Okay. Good. Neither is secant, right? Secant of theta, that's secant of 3 pi over 2, but that's 1 over x, so that's also not defined, because x is 0 here. Cosecant of theta is cosecant of 3 pi over 2, okay? But that is 1 over y, so that's 1 over -1, which is -1. And finally, cotangent of theta is cotangent of 3 pi over 2, right? So that's going to be x over y, so that's 0 over -1, which is 0. So that's what happens at 270 degrees, okay? Which is 3 pi over 2 radians.